Hello students, welcome to EPG Pathshala. I am Dr. Nidhi Handa from Gurukul Kangdi Vishwavidyalaya Haridwar. Today we are going to talk on module continuous distribution, normal distribution, standard normal probability curve under the paper quantitative techniques for management decisions. After completing this module, you should be able to understand the introduction of normal distribution, different characteristics of normal probability distribution, then its empirical rule, different tables are given, standard normal distribution is also discussed, related problems are given, then summary. The normal distribution. A very important continuous probability distribution is the normal distribution. It is applicable to many situations in which it is necessary to make inferences by taking samples. The normal distribution comes close to fitting in actual observed frequency distributions of many phenomena, including human characteristics, for example, weights, height, and IQs, output from physical process, for example, dimension and yields, and other measures of interest to the managers in both the public and private sectors. Different characteristics we can discuss. First, characteristics of normal probability distribution. The diagram also suggests important features of normal probability distribution. The curve has a single peak. If you see the curve, it has a single peak. Thus, it is unimodal and it has the bell-shaped curve also. Secondly, the mean of a normally distributed population lies at the center of its normal curve. Because of symmetry of the normal probability curve, the mean, median and mode, all the three will lie on the same point. You will see on x-axis. Fourth is the two tails of normal probability curve extend indefinitely and never touch the horizontal axis. To define a particular normal probability distribution, we need only two parameters, the mean, which is denoted by mu also, and the standard deviation sigma. So these are the main parameters of this distribution. Empirical, if we talk about the empirical rule, further in the discussion on the use of standard deviation, we also discussed the empirical rule for a bell-shaped curve. That empirical rule is based on the standard normal distribution table. By using the normal distribution table, we can verify the empirical rule as follows. Now see in the figure, the total area within one standard deviation of the mean is 68.26%. This area is given by the sum of the areas between z is equal -1 to 0, then 0 to 1. Between -1 and 0 and z is equal 0 to 1. As shown in figure 1, each of these two areas is 0.3413 of 34%. Consequently, the total area between z is equal -1 to 1 is sum of these two, so 68.26%. So total area under the curve is which is shaded area, 68.26%. After explaining figure 1, the area within one standard deviation, we will take second figure. The total area within two standard deviations of the mean is 95.44%. This area is given by sum of the area between z is equal minus 2.0 and z is equal 0, and between z is equal 0 and z is equal 2.0. As shown in figure 2, each of these two areas is 0.4772 or 47.72%. Hence the total area between z is equal minus 2 and z is equal 2 is 95.44%. If we see into the table corresponding value, we will see z is equal to 2.0 and corresponding to it we will see the tabular value in the table. We will find that the area is 0.4772. So on the right hand side 0.4772 is the observation which is set between 0 and x, and the second for minus 2 to 0 is again corresponding to this x value. The corresponding value is 0.4772. So take sum of these two values and we have the area between minus 2 to 2. Hence the total area. Now in figure 3, the total in 3 standard deviation of the mean is 99.74. This area is given by the sum of the areas between z is equal minus 3 and z is equal 0, and between z is equal 0 and z is equal 3.0. That is negative side and positive side. On the x-axis, if we see from left side to right hand side, as shown in figure 3, each of these two areas is 0.4987 or in percentage 49.87. Again, we look into the table, the values corresponding to z is equal 3, then the corresponding value will be 0.4987. Therefore, the total area between z is equal minus 3.0 and z is equal 3.0 is 0.4987 plus 0.4987. This comes out to be 99.74. So the total area between minus 3 to plus 3 is shaded area in the figure 3 from left side to right hand side, and this area is 99.74. That is more than 99% area is covered under x minus 3 mu and x plus 3 mu. Once again, I tell you that the curve does not touches the x-axis. It is on the right hand side and on the left hand side. It can be extended indefinitely. So rest of the values after 3, because in the table it contains value up to 3, z is equal 3.09, and after that 50%, we say that 50% of the area covers the left hand side, and like accordingly we solve the questions. Again, after the different rules, note that only a specific bell-shaped curve represents the normal distribution. Now we can state that a bell-shaped curve that contains 68.26% of the total area within one standard deviation of the mean and about 99.74% of the total area within 3 standard deviation of the mean represents a normal distribution curve. The standard normal distribution table A only goes up to z is equal 3.09. This is very important to students for you to attend to it. In other words, that table can be read only for z is equal 0 to z is equal 3.09. And similarly from on the left hand side, z is equal minus 3.09, and on the right hand side z is equal plus 3.09. Because of symmetry of the curve, half of the area lie on the left side and half of the area lie on the right hand side of the curve. Consequently, if we need to find the area between z is equal 0 and a value z greater than 3.09, or between a z value less than minus 3.09 and z is equal 0. You can see it from the figure also. Under the standard normal curve, we cannot obtain it from a normal distribution table because it does not contain a z value greater than 3.09. You can see in the table. In such cases, the area under the normal distribution curve between z is equal 0 and any value greater than 3.09 or less than minus 3.09 is approximated by 0.5, because the whole area under the curve is 1.0%, that is 0.5% area lie on the left hand, 50% of the area lie on the left hand side and 50% lie on the right hand side. From the normal distribution table, the area between z is equal 0 and z is equal 3.09, you will see from the table A, is 0.4990. Okay, hence the area between z is equal 0 and any value of z greater than 3.09 is greater than 0.4990, and which can be approximated by 0.5 only. The standard normal distribution. The standard normal distribution is very special case of the normal distribution. For the standard normal distribution, the value of mean is equal to 0 because we subtract x value from mean, and the value of the standard deviation is equal to sigma. This the normal distribution with mu is equal 0 and standard deviation sigma is equal 1 is known as standard normal distribution. Figure 4 displays the standard normal distribution curve. The random variable that possesses the standard normal distribution curve are denoted by z and are called z values or z score. So on the x-axis, now we convert it to z values. This is z value on x-axis, and in this curve mu is taken as 0 and sigma is 1, then it is known as standard normal distribution curve. The equation of normal distribution is given here, which is fx is equal 1 upon sigma under the root 2 pi into e raised to power minus 1 upon 2 in bracket x minus mu divided by sigma whole square. So this is equation for normal distribution, probability distribution function for normal curve, where e exponential is given to be 2.71825 and pi is taken as 3.14159 approximately. Fx, called the probability density function, also gives the vertical distance between the horizontal axis and the curve at point. For the information of those which are familiar with integral calculus, the definite integral of this equation from a to b gives the probability that x assumes a value between a and b. Z values or Z scores. The units marked on the horizontal axis of a standard normal curve are denoted by Z and are called the Z value or Z score. A specific value of Z gives the distance between the mean and the point represented by Z in terms of the standard deviation. In figure 4, the horizontal axis is labeled Z. The Z values on the right side of the mean are positive and those on the left side are negative. The z value for a point on the horizontal axis gives the distance between the mean and that point in terms of the standard deviation. Students, you can see it again in the figure 4 very carefully. For example, a point with the value of z is equal to is 2 standard deviation to the right of the mean. Similarly, a point with the value of z is equal minus 2 is 2 standard deviation to the left of the mean. The standard normal distribution table, table A, lists the areas under the standard normal curve between z is equal 0 and the values of z from 0.00 to 3.09. To read the standard normal distribution table, we always start at z is equal 0, which represents the mean of the standard normal distribution. We learned earlier that the total area under a normal distribution curve is 1.0. We have already studied. We also learned that because of symmetry, the area on either side of the mean is 0.5 as shown in figure 5. Note that although the values of z on the left hand side of the mean are negative, the area under the curve is always positive. It is always in absolute terms. Area cannot be taken in negative. The area under the standard normal curve between any 2 points can be interpreted as the probability the z assumes a value within the interval. Following examples will describe how to read table A to find areas under the standard normal curve. Let us do example. Example number 1. Find the area under the standard normal curve between z is equal 0 and z is equal 1.95. All the questions and all the exercises which are to be done, we will do it under standard normal curve only, because we consider the table of standard normal curve only. So we start the one question. We divide the number 1.95 into two portions. 1.9, the digit before decimal, and one digit after the decimal are taken. And now 0.05 is left, so 0.05, the second digit after the decimal. Note that 1.9 plus 0.05 is equal 1.95. To find the required area under the standard normal curve, we locate 1.9 in the column for z on the left side of table 1 and 0.05 in the row for z at the top of the table. If the entry where the row for 1.9 and the column for 0.05 intersect gives the area under the standard normal curve between z is equal 0 and z is equal 1.5. The relevant portion of table A is reproduced below as table 1. From table 1, the entry where row for 1.9 and the column for 0.05 cross is 0.4744 with red ink. Consequently, the area under the standard normal curve between 0 and z is equal 1.95 is 0.4744. This area is shown in figure. It is also helpful to sketch the curve and mark the area which we are determining. So see the table and find the corresponding value corresponding to z, the area. So the area is 0.4744. The area between z is equal 0 and z is equal 1.95 can be interpreted as the probability that z assumes a value between 0 and 1.95. That is, we will write down like this: the area between 0 and 1.95 is equal probability such that z takes value greater than 0 and less than 1.95. That is 0 less than z less than 1.95 is equal 0.4744. So like this we will take up this problem. The probability that a continuous random variable assumes a single value is 0. Always remember. So probability that z takes 0 value and probability that z takes 1.95 is always 0. And hence the probability that z takes value between 0 and 1.5. So notice it, see it carefully, that the probability that z lies between 0 and 1.5 is equal probability that 0 is less than equal to z less than equal to 1.95 is equal 0.4744. Now plot this area in figure bell-shaped curve. So figure 6 is area between z is equal 0 and z is equal 1.95. Shaded area is already done for 0 and 1.95. Example 2. Find the area under standard normal curve from z is equal minus 2.17 to z is equal 0. Because the normal distribution is symmetric about the mean and the area from z is equal minus 2.17 to z is equal 0 is same as the area from z is equal 0 to z is equal 2.17. As shown in the figure, it is clear from the figure also. To find the area from z is equal minus 2.17 to 0, we look for the area from z is equal 0 to z is equal 2.17 in the standard normal distribution. To do so, first we locate 2.1 in the column for z in that table. Then we read the number at the intersection of the row for 2.1 and the column for 0.7. Again we are dividing the 2.17 into two parts, 2.1 and 0.07. So the relevant portion of the table A is produced below as shown in table 2. This figure is, you can see that this is 0.4850. So we will see again the figure A from z is equal minus 2.17 to z is equal 0, because the area remains same. It is negative area is nothing. So the shaded area is 0.4850 on the left hand side. When the z value is in negative, then we will plot it on the left hand side. When z value is positive, then we will plot it on the positive side. This is very clear. Next is find the following areas under the standard normal curve. Number A, area to the right of z is equal 2.32. And second is area to the left of z is equal minus 1.54. So area to the right of z, as mentioned earlier, to read the normal distribution table, we must start with z is equal 0. To find the area to the right of z is equal 2.32. First we find the area between z is equal 0 and z is equal 2.32. Then we subtract this area from 0.5, which is the total area to the right of z. From table A, the area between z is equal 0 and z is equal 2.32 is, we will see, 0.4898. Because required area is to the right of z is equal 2.32, so we will find out this by subtracting this area from 0.5. So 0.4898 is the area between 0 and 2.32. Always the values which we take from table, that gives between 0 and the z value. and to the right of z we can find out by subtracting from 0.5. That is half of the area, that is 50% of the area. From 50% of the area we subtract the value and we will get the other value. As shown in the figure, you can make it clear. The area to the right of z is equal to 2.32 gives the probability that z is greater than 2.32. Thus, the area to the right of 2.32 will be shown as probability z is greater than 2.32 is equal 0.5 minus 0.4898 and it will be 0.0102. Now B part. To find the area under the standard normal curve to the left of z is equal minus 1.54 from the table. First we find the area between z is equal minus 1.4 and z is equal 0, and then we subtract this area from 0.5 naturally to the left of z. So from table A, the area between z is equal minus 1.54 and z is equal 0 is 0.4382 and hence the required area is 0.5 minus 0.4382 which is equal to 0.0618. This area is shown in the figure also. So area to the left of minus 1.54 is written as probability such that z is less than minus 1.54 is equal 0.5 minus 0.4382 and hence the answer. Now next example, suppose the training program director wants to know the probability that a participant chosen at random would need between 550 to 650 hours to complete the required work. Mean is 500 and standard deviation is 100. So the probability is represented by shaded area in the given figure. Step 1. First take it into standard normal form, which is z is equal x minus mu upon sigma. Mu is subtracted from x. This is standard normal form and divided by sigma. Put the values, solve it. We look up at z is equal 1.5. After solving, we get z is equal 1.5, and in normal distribution table, if we see and find the corresponding probability value as 0.4332. That is probability of z which is 1.5 is equal 0.4332. So area between 0 and 1.5 is 0.4332 because we need the area between 500 and 650. So again we calculate value of z when x is equal 550 and we have already x is equal mean is equal 500. So subtract it. 550 minus 500 divided by 100. So this is 50 upon 100, that is 0.5. Next z is 0.5. So corresponding to 0.5 we will see the area, and from table we find that the corresponding value is 0.1915. Next, so at 550 it will be from 0 to 550 the area is 0.1915. Next, step 3. To find the final answer, that is the probability that the random variable will fall between 650 and 550 hours. So 650 and 550 hours, by figure you can observe that this will be probability such that random variable will lie between 650 to 500 is equal 0.4332 minus probability that random variable will lie between 550 and 500 is equal probability that random variable lies in the shaded area, that is between 550 to 650, is equal 0.2417. So in this way we will solve this problem. In next example, An aptitude test was conducted on 900 employees of the Metro Tyres Limited, in which the mean score was found to be 50 with standard deviation 20. On the basis of this information, what was the number 1 number of employees whose mean score was less than 30? Number of employees whose mean score exceeds 70, and third is number of employees whose mean score between 30 and 70. So mu is given, sigma is given, and the problem is that x is less than 30, that is mean score was less than 30. So x minus mu upon sigma. First we convert it into standard normal form. So z, because z is x minus mu upon sigma, and both sides we subtract mu and divide by 30. So this comes out to be probability that x minus mu upon sigma less than 30 minus mu upon sigma, and we will substitute the values and we get that probability z is less than minus 1. So less than minus 1 we can shade it in the figure. We can shade the area in the figure, that is z is less than minus 1. So probability, this can be expressed as probability such that minus infinity less than z less than 0 minus probability minus 1 is less than z less than 0. So once again understand this step, that probability such that minus infinity is less than z less than 0, this probability is from 0 to minus infinity, then subtract it, minus p minus 1 less than z less than 0. So this area will be lessened. So probability is 0.5 for minus infinity to 0 area, and minus the tabular value which is 0.3413 corresponding to z is equal 1. So subtract it and we have area between z is less than minus 1 is 0.1587. Once again I am repeating that we want to find out the area of probability that z is less than minus 1, that is on the negative side. So area between minus infinity to 0, that is central point, z is equal 0, is 0.5. Subtract the other area which is probability such that minus 1 is less than z less than 0 is subtracted from 0.5 and we have the value. Next, B part, number of employees whose mean score exceeds 70. So x is greater than 70, and like this first we will convert it into standard normal form. So 70 minus mu upon sigma, and we have probability z greater than 1. So on the right hand side of the curve we will again do it like this, 0.5 my 0.3413 will be subtracted from 0.5 and this will be the result, required result. Then the third is number of employees whose mean score lies between 30 and 70. So again we will write like this, probability 30 less than x less than 70, and we will convert it into standard normal form. For this we have to subtract mu from all the entries and divide it by sigma. So we have probability minus 1 less than z less than 1, and accordingly you will find the values corresponding to table. The number of employees whose mean score was greater than 70, corresponding probability we will take and multiply by 900, then the score will come. Similarly, the number of employees whose mean score was less than 30, again we will take the corresponding probability and multiply by 900 and so on. Next example, in a normal distribution 7% of the items are under 35. and 89% are under 63. What are the mean and standard deviation of the distribution? This is peculiar type of examples. Probability x is less than 35 is because 7% of the items, so we will write down 0.07. Then 89% are under 63, so x less than 63 is equal 89%, so we will write down 0.8. Now for x is equal 30, because we have to be particular, we have to take x is equal 30. Z we will find out by subtracting from it mu and divide by sigma, and we don't know the values of sigma and mu. Call it Z1 and Z2, like for x is equal 63, 63 minus mu upon sigma. Since 7% are under 35, so clearly on the right hand side we will mark 7% and we will subtract 7 from 0.5, this is 0.43. So on the left side 7% and 43% will be marked in the curve. Then 89%, subtract 0.89 from 0.5, 0.5 from 0.89 we have 0.39. So 0.39 on the right hand side we will mark, and rest is 11%, so rest of the area is 11% or 0.11. So we will solve it accordingly and using the given probabilities. We have one is 0.07 from figure. The second probability is subtracted 0.5 minus 0.47. 0.5 and 0.7 we will get 43. So you can see that the area 0 less than z less than z2 is 0.43, and area that 0 lies between z and z1 is 0.39. From table z2 is equal 1.48, we want to know that how this value come. Z1 is equal 1.23 and Z2 is equal 1.48. Since the corresponding value is 0.43, because the area is 43% and we will convert it into decimal, then this is 0.43, and we will go to the table and we will select the value for it. 0.43 we will see into the area. Since different areas 0.4292 is corresponding to Z value 1.47, and the next value 0.4306 is corresponding to Z value 1.48. Since the 43% area is more near to 0.4306 than 0.4292, so I will not take up the value 1.47, I will take up the value 1.48. Similarly for Z when we choose the value 1.23. So value of Z corresponding to the given probability is now 35 minus mu upon sigma is 1.48 and 63 minus mu upon sigma is 1.23. Now mathematically we will solve these two equations and for two unknowns, and we will get the values of mu and sigma. Of a large group of men, 5% are under 60 inches in height and 40% are between 60 and 65 inches. Assuming a normal distribution, find the mean height and standard deviation. Again, the question is to find out mu and sigma. So according to the question, according to given condition, we have probability x takes value less than 60 is 0.5, and probability that x lies between 60 and 65 is 0.40, that is 40%. So the values accordingly from figure you can see that Z we will first convert into standard normal form, so 60 minus mu upon sigma is equal Z1 and 65 minus mu upon sigma is equal Z2, and we will solve because of symmetry minus Z1 is less than Z is less than 0 is same as 0 less than z less than z1, and we will find the entries, corresponding entries. Because they are on left hand side, so negative values will be considered, and find out values for sigma and mu and have the answer. A random variable x is normally distributed with mean 12 and standard deviation sigma. Find the probability. When given conditions are probability that 9.3 less than x less than 13.8, given that x upon sigma is 0.9, a is equal 0.3159, and x upon sigma is equal 1.2, a is equal 0.3849. So this is not very typical question, although it looks like to be a typical. We have to find the probability of x between 9.6 and 13.8. So we have mean is equal 12 and sigma is equal 2. So when we subtract mu value from x, then we will see that we have, rather we convert it into standard normal form, then we have probability such that minus 1.2 less than z and less than 0.9. We will see the table and take the values, tabular values, and sum it and have the answer. So the students, let us now summarize what we have learned in this module. The standard normal distribution is a special case of normal distribution. For the standard normal distribution, the value of mean is equal to 0 and the value of standard deviation is equal to 1. The values, the z value or z score, which is known as standard units or standard scores, they represent random variable that possesses the standard normal distribution. To see the tabular values for finding area under the curve has been explained here. Different problems are also taken into consideration and their solutions are also given. Thank you.